Hi, I'm Paul Hopewell. Welcome back to my workshop. This is part 2 of 2 videos where I show you what I went through to make the Mark II version of my drill sharpener. In the last video I made the base plate, a collection of rings, a support plate with arms, a cam and a link. In this video I'm going to make a ratchet, the spring, pins and bolts before finally trying to recut some junked drills. It's also worth reminding you that the drill sharpener is an experimental project, and although the drawings are CAD drawings, I've changed things as I've gone along for one reason or another. And as we all know, if you change one thing, there are repercussions further down the line. Right, I'll start this video with the pivoting support arms. Just to explain, the selected drill bit is to be held via a collet within a collet tube. This tube is in turn held in place by an outer sleeve or an outer tube. To hold or support this outer tube will be 2 rings that will in turn be held in place by the pivot arms you see here. What I'm marking out are the holes that allow these arms to be bolted to the rings. They are both to be 6.2mm diameter. Here I'm running a layout line all round this arm because I want to check that the eventual recess that will be put here won't interfere with anything else or burst out of the sides. I need some kind of guide to control the relief angle here, and this face was set aside for this purpose. There will be a blind 6mm tapped thread supporting a pin perpendicular to this face. This face is designed to sweep against a side plate. After setting this, the smallest of the 2 arms in the milling vise, a centre drill was used to help prevent the drill wandering when I open it out to 5mm ready for tapping. With the first side done, the arm was turned over to drill 2 holes, again using the centre drill first, then a 6.2 clearance drill through. The distance between the 2 holes was noted. The last job on this arm is to countersink for a 6mm cap head screw. I used an 11mm 2-flute cutter for this. For the moment all I need to do to the longer of the 2 arms was to drill 2 6.2mm through holes, making sure that I cut them at the same distance apart as the other 2. After I found my bit of paper, on the previous video you saw me machine these rings. Now I need to mark the largest ones up for drilling and tapping, but there are some exceptions. One of the rings already has 2 sets of opposing 6mm threaded holes, and one of the sets of holes needs to be blocked off. The thing is, both of these rings are oversized by about 2mm. So I started the reclaimed one first in the mill, to machine a flat centrally over one pair of existing holes with the intention of getting the bore central to the 2 flaps. With the new ring, all I had to do in the first instance was hold it in the vise and skim over the top, making sure it didn't remove any more than 0.75mm from the overall diameter. To machine the opposite and subsequent sides of both rings, I simply placed a milling spacer flat in the vise. The spacer lay in the void between the 2 hardened jaws, bridging the 2 cleaned bottom jaw guides. This provided a surface for the ring to find its own centre with a bit of help from gravity. This method allowed me to piecemeal each side until I achieved the required dimension across the flats while keeping the bore central. Yeah, I'm happy with that. The reused guide already sports a pair of 6mm threaded holes and no longer requires further work. This is designated as the front guide ring. The other ring does need further marking out. Firstly, for two horizontally opposed 6mm threaded blind holes. Letting the ring settle on one of the two flaps allowed me to run a scribe block that's set to a nominal height across the front, leaving a line parallel to the two flats. The odd leg scribe is set to a nominal opening to cross the previous scribe mark. Spotting the centre of the crosshairs lightly provides a centering reference. This time using a pair of dividers, again set to a nominal opening, provides two further crosshairs that can now represent the screw hole centerline. Using the center finder confirms that the line is central and in line with the center of both flats. Sitting the ring on a T-block so that the centre line is parallel to the surface plate and the scribe block. The centre line can now be extended around each side. Using the odd legs once more, this time to set the centre of the workpiece, makes a couple of crosshairs that when spotted will become the centre of the 6mm screw holes. It's up to the centre drill first to set the position for the 5mm drill, then they're going to be tapped to 6mm later. Both these screw holes are blind holes, so they're not allowed to break through. Now, despite my initial decision not to include sprung interlocks in the rear guide rings, I changed my mind and decided to include them again. I guess that with sprung interlocks they'll assist the manual release interlock to positively re-engage without having to wiggle the outer tube. I set the centre line using the same process as before, then scribed around the ends using a V-block and a scribe block before spotting the two through holes. I've got two sets of interlock positions, one set at the back here and the other to be set below the longest pivot arm. I had to assemble these components in order to get the interlock positions set as true to each other as I could. You can see here that both of these threaded holes are offset to the outer tube collar. So I set the hole to be drilled in the pivot arm to suit. After marking out and spotting, the hole was drilled through and into each of the collar hole positions. The drill might look like it's been on the bottle, but it's actually a camera lens error. The drill I used was a 5.8mm, but I followed up with a 6mm reamer. My next task is to cut in the one-way ratchet teeth. You can see all the old marring left by various setups with the previous Mark 1 cutter here. Bluing the outer tube like this was done so that I could set the ratchet positions away from the front support collar. Marking out positions of both the front support ring and the ratchet ring is quite a simple process. You can see here I've got to get the ratchet teeth between these two lines. You can also see one of the two indents for the sprung-loaded interlocks here. What you see here is my universal indexing head. It's set for a horizontal cut paired to a centered tailstock. And in it I've mounted the outer tube using a bung on the tailstock end because the bore of the tube was too big not to use it. In the quill is a 16mm 4-flute cutter. I've set the cutter so as not to cut into the bore. Once I'd got the cutter somewhere near where I wanted it, I set the cutter to depth to just touch the tube's OD. Then I reset the cutter position and plunged down 8 times. That should do. The indexing ring is going to get a hole drilled on one side for a handle and a slot cut into the bore to take a reshaped woodruff key acting as a pawl. I'm using a 5mm wide woodruff cutter to cut into the centre of the bore on this index ring. Using a cigarette paper to touch onto the top side, I then set the cutter height to cut centrally in the bore. That's the woodruff slot finished. Well, almost, because I did put it back in to extend it a bit later. A woodruff key, as I've said before, is going to be used as a pawl once it's been hand shaped to the right profile. This means I've got to take a little bit off the key's flat side to allow the whole index ring assembly to slide onto the outer tube later. The work involving the pawl was mostly guesswork. You might say a suck it and see process. After the best guess process had been carried out, I was so relieved that it worked I had to go away and fan myself. The hole in the pawl was drilled at 0.2mm bigger than the hole in the index ring. Then, when satisfied when it was finished, I removed the drill bit and replaced it with a copper rivet and jammed it in using the vise. I rubbed the knobbly bits off with the aid of a belt sander. And after making an old biro redundant by relieving it of its spring and cutting it down, I'll shove it in the hole I drilled at the back of the pawl when I'm ready to assemble everything. All that's left to do on this ring is to drill and tap a 6mm hole about 10mm deep, anywhere on the OD providing it's not over the slot. After drilling the 5x10mm deep hole, I spot faced around the hole to accept a lock nut if one is needed. Mind you, looking at the spot face, I think I must have moved something because it looks as though it's on the proverbial urine. The side plate's job is to prevent the device from upwardly over-rotating the drill bits. And before I marked it out for the radius slot, I carved an outer radius with a stop at the bottom. This is to prevent the drill bits from being over-rotated in the opposite direction. You saw a couple of seconds earlier that I set it up using the dead centre that has a dimple in its tip. This helps me to set jobs like this true to the centre of rotation. This curved slot was formed by bluing the side plate, then clamping it to the support plate, and using a grub screw in the fitted short arm, I moved it through its predicted range of movement a few times to get a scribed mark on the side plate. It was still a bit of a monkey to get it true though, while sitting the component on suitable packing. Again, I started the slot by first plunge cutting with a 5mm 2-flute mill-end cutter, then completed the sweep making the slot 6mm wide. Here it is, fitted and in action. Obviously this part of the assembly when fully built is going to weigh quite a bit, so I'll need a strong spring to counteract this. I hadn't planned for this in my drawing, so I need to get my thinking cap on. I've got a box full of bits and bobs, and after circling about in it for half an hour I came up with a bunch of bits that, with very little work, made what looked like a car-type shock absorber. I found a strong spring, a bit of plumber's copper pipe, a short piece of stainless steel tube and a couple of bits of brass. I figured that if I drill a couple of 6mm holes partway through the long arm and the support plate base, I should have something to work with after I machine the 2 bits of brass to suit. One of the brass bits are going to be turned to fit into the stainless steel tube. The other one is to fit into the end of the spring that is shrouded by the copper tube. These little brass pieces are going to be sat in and drilled whole. With a bit of luck they will stay there under compression. The dome ends are going to act like little ball joints. Assembly is really quite simple, they just push together. The 2 halves will separate, fall apart really is what I mean, but kept under load they shouldn't be a problem. After marking out the 2 best guess positions on each part, I drilled them 6mm diameter deep enough to prevent the spring unit from springing out. I hope. The reason for drilling a total of 4 little recesses is to be able to move the top or bottom of the spring from hole to hole to get the best tension and movement. All I've done here is temporarily shove the drill tubes into the swivelling assembly to load it up, and it works well. This pin was made to slide through both the cam and the link arm. One end of this pin is a few thou bigger and needs to be forced in. This interlock pin will be threaded 6mm and a hard wooden knob will be made to fit. The small end will have a spring fitted to make sure that the pin locks in place. These pivot hinges were a good fit, but the material was too soft for the job, so I eventually replaced them with remachined 6mm cap head screws. After re-reaming the pivot holes out to a new size of 1/4 inch. side plate stop pin was originally a 6mm cap head screw. Again, it was machined to size. These screws, along with others, were turned into slot head screws. The method I used to cut the slots was the two-bladed hacksaw method. The screw holding the cam in position was made with an integral top washer. This support plate screw was made with two tasks in mind. Firstly, to prevent the support plate from closing beyond a certain point with it being in a slot. Secondly, to maintain a level of downward pressure on the support plate by using a penny washer and a flat spring. This is not every pin, screw and bolt, but it gives you an idea of what was needed. At long last, it's time to put the whole thing together. Most of the items here are reclaimed from the Mark I drill sharpener. Starting with the index tube, it is first cleaned to be fitted with the front support collar and checked for free rotational movement only. This is followed by the indexing ring. This ring has a Pawl fitted in it, and it must have a small spring fitted before it's assembled to the outer index tube. It in turn is held in place by a locking sleeve, held in place by one grub screw. The final ring, the rear support collar, is also added to this assembly now. This is where the two sets of steel balls and springs are inserted in place and held in place using grub screws. Only the tops of these interlock holes are threaded to prevent the springs from trapping. And before I went too far, I checked as best I could that they did engage. More importantly, that they weren't too difficult to break free. The support arms are next, and it doesn't really matter what order they're fitted in, except that I've got to remember to fit the manual interlock pin, which you'll find here I've got to take it all apart again just to fit that pin. This is where I fitted the inner setting tube. Its job is to present the drill bit cutting lip into alignment. It is firstly screwed in and down to the indication mark on the threads, but it doesn't necessarily need the collet or collet cap on yet. The thimble is slid onto the back end of the inner setting tube to partly cover the outer indexing tube. And it is locked into place with a grub screw utilising the flat on the inner setting tube. Another extended grub screw is fitted into the hole provided for it in the outer index tube. Then a clamp plate shaped to fit is held in place by one fixing cap or a wing nut. I later found, however, that the cutting action caused this clamp to slip. To prevent this happening, I put a piece of folded emery cloth between the clamp plate and the thimble. That seemed to work. This seems a good point to quickly fit the missing manual interlock. I was going to use very hard wood to make the handles or knobs, but I had some Tufnell and I decided to machine all four of them on the wood lathe. I mounted the support plate on top of the base plate at the pivot point using a slightly modified 8mm bolt through an 8mm flat spring. Next was the spigoted stop pin. This screw is first fitted with an 8mm flat spring that sits over the spigot, allowing a 6mm penny washer to follow. The screw is then tightened into the base plate with some Loctite thread locker. I now found that I needed a ground washer underneath my cam because I'd altered something earlier. Still, that didn't create too much of a drama. After the link arm pivot screw was fitted and secured in place with more thread locker, the handle and other Tufnell equipped bolt was attached to the cam. The cam was tested until the amusement waned. Despite how it looked, the lever was only just under load as the cam reached full reach, which is what I was after in the first place. I'm now fitting the pivoting assembly to the support plate using the two pivot pins you saw me making earlier, and I'm also fitting some spacer washers. I did say earlier that I replaced these two screws with remachined cap head bolts, but these harder screws were in fact fitted a little later. Once the pivot screws were set in place, the pivot arms could also be tightened, at which point the whole assembly became very taut. It felt reassuringly purposeful. The counterbalance spring is now sporting some Go Faster stripes on it now. Its marks made in the copper pipe using a pipe cutter with a blunt blade. This made the stainless steel lower tube fit much closer. Held in place with two screws, the side plate can be fitted once the spring is put in place. This will stop the sharpener's cutting action to remain within a set sweep. With the side plate in place, I found that the black paint I used to coat almost everything was causing the pivot action to stick, so I had to strip the side plate off again to clean the swept area of paint from both parts. Testing proved to be a little frustrating at first. With everything being new, the ratchet clicked like a Colt 45 shell chamber, but the interlock release was stiff. Beside that, the manual interlock refused to lock back into place. It was all frustrating at first, but after undoing and retightening the support arms, everything clicked and snapped into place like it should have done in the first place. Right, I've built the unit, but I don't really know how to use it. What I mean is that this is where the real work begins. I'm not going to use good drills to do the first tests with. I've got a bunch of busted drills that I can use first to set everything up and find out how to get on. These videos, of course, are showing you my first cuts as I did them. I wasn't going to do a few and then let you see how I started them. This is actually how I started to learn to do them. This first drill is probably the worst one to start with because it's an old busted 4mm wood drill. What you see here is me messing about and trying to establish how far out the drill needs to be, how far round the drill needs to be to present it to the wheel, and eventually, is it the same rule for all sizes? I should also point out that this cutting wheel is too coarse for this work, but I do intend to buy a couple of new wheels soon and that should do a much better job. Sorry that the video is a bit poor here, but in truth the finish of this drill tip was a bit crappy anyway, so it wouldn't have made a lot of difference. It was no good at this point. This time, and after a few old drill bits had been ground to a pile of dust, I feel I've now got a working formula. This is a rusty worn out 10mm drill. It's supposed to be 10.2mm, but its actual size is around 10.16mm, nearest to the cutting edge. The margin is quite worn near the tip, but further down the body it's nearer 10.19mm. The first thing I did with this drill bit was put it in the drill press and make a hole 5mm deep. Then I measured the outer diameter of the cut. But because this drill was previously hand sharpened, probably many times, it probably wouldn't surprise you to learn that the resulting hole was nearly 10.4mm diameter after I'd gone down 5mm deep. The oversized hole is likely down to the drill bit cutting edges, that is, one cutting edge being slightly longer than the other cutting edge. My settings on this cutter at the moment are that the edge about to be cut must be on a line directly on centre of the pivot point axis, and that the cutting lip must lie parallel to this same pivot axis. Once set, the thimble setting must be nipped up tight. I found that the centre of the cutting wheel must be about 5 to 10 degrees below the drill centre. I haven't got a side-loaded cutting stone for my grinder yet, but I believe the wheel height won't matter in this case, nor do I believe that it would make any difference on a belt sander. I haven't tried that yet. After a bit of trial and error, I've finally pulled together the formula that wins it for me. Well, for now. I'm not saying it's perfect, I'm saying I've still got work to do, but I'm close. This is the bit of bar I used for the test piece, showing the first cut using the drill as it was, and right alongside it the new cut with the sharpened drill. That's not bad. Because I was feeling a bit braver now, I had a go at sharpening one of my better drills. This is a broken 3mm drill bit that I flattened the top off to see what I can do with this cutter. After shoving it in the collet and getting it as close as I can, this 3mm drill is a bit difficult to see if it's set up properly, so it looks like I'm going to have to make some setting tools. This one is the biggest drill that I've sharpened so far. It didn't grab and it did a clean cut. The other thing is it didn't leave a burr on the back either. This is the rusty 10.2mm drill bit. Like the bigger drill, when it broke through there was no burr on the underside of the workpiece. And now for the 3mm drill that I snapped off near the end of the flute body. I won't drill all the way through because the material is much deeper than the flutes are long, so they could jam up if I tried to drill right through. That's all for this project. I hope you've enjoyed the video. Thank you very much for watching and I'll see you again soon. Bye for now. Bye.